Hello, good day viewers. Remember, I promised to start talking about complex numbers from scratch. So in this tutorial, we are going to make an introduction about these complex numbers. Last year, I have discussed about numbers, where I made series of videos on real numbers, including imaginary numbers. So a complex number is just a combination of real numbers and imaginary numbers. This implies that both real numbers and imaginary numbers are a subset of complex numbers. So let's read this information here. It stated that a complex number is a number written as a plus bi, where a and b are real numbers and I is an imaginary number defined as the square root of -1. As the set of real numbers is denoted by this r, likewise the set of complex numbers is denoted by this type of c. So an example of a complex number, which is normally represented by z, is equal to 2 plus 3i. This is just an example because we have learned that both a and b are real numbers. So a here is equal to 2 and b is equal to 3. This implies that a complex number has real and imaginary parts. For any given complex number like z equal to a plus bi, a right here is the real part, while bi right here is the imaginary part. But some people might ask, we have seen that b is a real number. Why should we call bi, the whole of bi, to be the imaginary part? B is just a multiple of I because I is an imaginary number. If you add it to another I, both of them are all imaginary numbers. Together you have two of them, 2i. Therefore, 2 here, which is a real number, is just a multiple of I, which determines the quantity of I in that part. But if you want to be specific about these real numbers a and b, this is how you can identify them. The real part, Re of z, is equal to a. That is the real part of the complex number z is equal to a. And the imaginary part of this z is just b. That is the multiple of our imaginary number here is b. We are talking about the imaginary part of z. It's only the coefficient of that I. But the real part is always the first term here. But the $1,000 question here is that, is a real number a complex number, or is an imaginary number considered as a complex number? Yes, because if z is equal to a plus bi, what if a is equal to 0? We know that 0 is a real number. Therefore, we have z equal to 0 plus bi. So you can see this is just an imaginary number bi, which is also considered as a complex number because the real part is equal to 0. So what if b is equal to 0? If b is equal to 0, we have z to be equal to a plus 0i. And 0i is just 0, so we have this implies that z is only equal to a real number. But this is also a complex number. This is also another complex number. Altogether, we have seen that both real and imaginary numbers combined together are subset of complex number. So this is just an introduction about this complex number. Subsequently, we are going to look onto the properties of these complex numbers. We'll look at the addition and subtraction, multiplication and division, conjugate, equations involving complex numbers, and so on. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos.